Now let us reverse a linked list by reversing links. Reversing links means this node 4, instead of pointing on node 6, it should point on 2, and 6 should point on 4, and 8 should point on 6, and 2 should become null. Now before showing you how to reverse, I'll show you one small concept, that is sliding pointers. Sliding pointers. I am naming it as sliding pointers. What I mean by sliding pointers, let us see. I'll take 3 pointers. One is pointer P, and pointer Q, and pointer R. Initially pointer P is pointing on first node, and Q is null, that is before it, and R is also null, that is before it. I am assuming that are before first node. Actually they are null, they are nowhere actually, but assume that they are here. Now this is the initial state. So what I want is these 3 pointers should slide. Slide means move. It is just like a tailing pointer. If you remember, one pointer P and Q was following it. Now R is following Q. So all 3 together are moving. So I am calling it as sliding. So let us see how I want them to work. See, first R should come on Q, and Q should move on to P, and P should move to next node. This is one movement, one step. Then continue. R should come on Q. Q should move on to P, and P should move to next node. See, all 3 are moving together. So that's why I'm calling them as sliding pointers. Then again, R should move on Q. Q should move on P. P should move to next node. So in this way, we can move 3 pointers together. So for that, I will write on the code here. Initially, P is on first, and Q and R both are null. Then in each step, what I am doing, R is coming over Q, Q is coming over P, and P is moving to next node. I want this to continue until P becomes null. So I can write a condition that while P not equal to null. So it will stop when P becomes null. So these are the steps for sliding pointers. So now you know what are sliding pointers. Now let us see how we can reverse the links. So I'll take a small example and show you what are the requirements for reversing the links. So I'll take 3 nodes. Assume that this is already pointing on the previous node. Then I have to reverse the link of this node so that it points on this previous node. That's what we want, right? 4 should point on 2, 6 should point on 4, means this node should point on the previous node. Now I have to modify this one. So let us take a pointer Q on this one. Then for changing Q's link to this node, I should know the address of this node also. So I'll have one pointer here, R. Then when this link is modified, this will be pointing here. Then where is the address of the next node? We lost the address. We don't have the address. Just now we were having the address of this node. If we modify it and make it point here, we will not get the address of the next node. So for that, we should also have a pointer on the next node. Let us call it as P. So we need 3 pointers. The node which is being modified, and the previous node, and the next node. So I am taking the names as P, Q, R. So what I should do, Q's link should point on R. This modification I should do. So this has reversed the link. Now I have to modify the link of this node. Beyond that, there are few more nodes. Assume that there are more nodes ahead. So I have to modify this node. So for that, Q should go there. Then R should come here. So R should come here. And Q should move to this node. And P should move to next node. Like there is some node again. So that's it. So it means this P, Q, R are sliding. So that's the reason already I have explained you what does it mean by sliding. So how to reverse this? Slide and reverse the link. They have slided. Then say Q's next assign R. That's it. So we need to do 2 things. Slide 3 pointers, and with the help of Q, reverse the link. So already I have the code here for sliding. So only one step is remaining, that is Q's next should point on R. So I will write on that code also. Q's next is point on R. So this is the extra line. Till here everything was for sliding, but now I have added Q's next as R. That's all. This is the procedure for reversing a linked list by reversing their links. Let me trace this and show you really it works on this example linked list or not. So I am tracing it. P upon first node. Okay, P upon first node. Q and R are null. Q and R are null. While P not equal to null, yes, P is not null. These are the steps. So the first three steps are for sliding. R upon Q, Q upon P and P on next node. R upon Q, so R is again null. Q upon this node. Then P on next node. So these three steps I have performed, slided. Then Q's next is R. So Q's next, this one is R. What is R? Null. So this is the first step. Continue. P not null. Yes, P is pointing on some node. Then slide them. These three steps. So R comes on Q. Q goes on P. P moves to next node. Three steps over. Now Q's next is R. Q's next is R. R is this node, so it is pointing on this node. Means here the address 200 will be written. Earlier it was 250, but now it is 200. Next, again continue. P is not null. Then slide them. R upon Q, R upon Q. Then Q upon P, Q upon P. Then P to next, P to next. Then Q's next on R. So Q's next is this one. This was having 300. Now this will point on R. What is R? Address 210. 210. R is a pointer pointing on this node, means it is having address 210. So that address 210 is written here. Continue. P not null. Yes, not null. R upon Q. R upon Q. Q upon P. Q upon P. P is null. P is next. So P became null now. Next, last step, three steps over. Q's next is R. So Q's next is R. So here what the address was null. So now what will be written? 250 will be written here. Continue. P not equal to null. No, P became null. Stop. So you can see that linked list is reverse. Now who became first node? Wherever Q is pointing. So the last step I will add, first should be upon Q. So we should bring this first upon Q. This is the first node now. First node is pointing on this node and this is pointing on this is, and the last node is null. So the linked list is reverse. So these are the simple steps for reversing a linked list. I have used the concept of sliding pointers and I have reversed it. So with the help of 3 pointers, it's possible to reverse a linked list. Now, as I said that we prefer modifying links for reversing a linked list. We don't prefer movement of data in a linked list. We don't prefer that 8 is brought in this node 200 and 2 is sent in this node 300. We don't want to change the contents of node. We want to reverse the link. Reason. See, in a linked list, as per the example, for learning purpose, we are taking only integers. Integers, 2 bytes, 2 bytes. We are just taking 2 bytes. But that need not be an integer always. It may be a record. It may be having a lot of values. For example, I'll show you. There is a node having roll number of a student, name of a student, address of a student, year of a student, department of a student, mobile phone number of a student. Then there is a link. So this whole record is there. It's not just one value like 2, 4, 6, 8. There is a complete record. So it's a linked list of records. Now if you say I want to bring that data here and copy. Now if you say I want to swap this data, then lot of contents have to be swapped. In our example, that are 2 bytes, 2 byte integers. But here, suppose this is 200 bytes. The size of this record is 200 bytes. Then you will be copying 200 bytes. So what is preferable? Copying just links, changing the pointers. Pointer, how much memory they take? They take 2 byte in 16-bit compiler or 4 bytes in 32-bit compiler. So again, that depends on the compiler. So pointer always takes same amount of memory. Let us say 2 bytes, for example, because in our examples we are calling integer as 2 bytes, so pointer also 2 bytes. So how much data you have to modify? Just 2 bytes pointer we have to reverse. That's it. So instead of reversing data, we prefer modifying links. So that's all. The procedure is very simple. Using sliding pointers, we have reverse a linked list. Now one more method I'll show you, reversing a linked list using recursion. So we'll see that